In the 1800s, pneumatic tires were developed. These tires are made of an airtight inner core filled with pressurized air. These tires were known to be successful among bicyclists. However, the only problem was that it was hard to add or take out air out of the tire if needed. August Schrader found a way to resolve the issue with the Schrader valve he produced around 1890. This was his most popular invention and is still used today. The valve allows air to be added into the tire or let out of the tire easily. The valve works by pressing a pin inside the valve, opening up an air canal to allow air in or out of the tire. To add air into the tire, you put the pump adapter onto the valve to keep air from being released and use the pump to add air into the tire. To release the air, the pin inside the valve just needs to be pushed inward.
We decided that the Schrader valve was an engineering feat because it deals with the mechanics of inflating a tire. The valve implements different physical properties like controlling the pressure inside the tire by using a spring to allow for airflow. Along with the physical problems that the Schrader valve solves, the fact that it solves these problems in the first place proves it to be an engineering problem in its own respect. And that's because engineering aims to solve everyday problems in our world, just like the problem of easily inflating tires.
In addition to tube and tubeless tires, Schrader valves of varying diameters are used on many refrigeration and air conditioning systems to allow servicing. It can also be seen on fuel rails of some fuel-injected engines, on bicycle air shock absorbers to allow adjustment of air pressure according to rider's weight, and in the buoyancy compensator inflators of scuba systems. Schrader valves are also widely used in high-pressure hydraulic systems on aircrafts. Many domestic fire extinguishers use an internal valve identical to the Schrader valve, but with a lever on top to enable quick release of the pressurized content.
The Schrader valve is considered the universal valve type in the world today. Nearly 100% of car tires worldwide use the Schrader valve. However, there have been a few modifications of the Schrader valve implemented primarily in bicycle tires around the world. The two primary modifications of the Schrader valve are the Presta and Dunlop valves. The Presta valve is used mostly in racing bicycles because of their thinner 6mm profile is more efficient with thin bike tires than the beefier 8mm Schrader valve. The Dunlop valve is used across Europe and in the Middle East primarily on bike tires and is the same size as the Schrader valve.